What you're seeing here is my smart desktop station, built from scratch using a Raspberry Pi Pico 2W. It combines a clock, weather information, temperature and humidity monitoring, and an alarm system into one compact desktop device. If you enjoy DIYElectronics, Raspberry Pi projects, and maker builds like this, be sure to subscribe, leave a like, and drop a comment below. Now let's take a closer look at how I designed this smart desktop station, the components I used, and how everything works together. If you're ready, let's get started. For the display, I chose the Waveshare 2.8-inch ResTouch LCD shield. It's compact, responsive, and works perfectly for this project overall. At the heart of this project is the Raspberry Pi Pico 2W. It handles all the processing, Wi-Fi connectivity, and communication between the different components. To make the assembly process easier, I prepared and soldered this board in advance for the display and Raspberry Pi Pico 2W. The wiring diagram and component connections can be found in the video description, but feel free to adapt the design and build the project in your own way. For temperature and humidity monitoring, I used a DHT11 sensor. It provides real-time environmental data, allowing the smart desktop station to display current room conditions. For the alarm system, I added a passive buzzer. When an alarm is triggered, it generates clear sound alerts to grab attention. This ensures that important reminders and wake-up alarms are never missed. To navigate through the menus and configure alarms, I used two 12x12 tactile push buttons. They provide a simple and intuitive way to control the smart desktop station. To ensure reliable button inputs, I added two 10 kilo ohm resistors as pull-down resistors for the tactile switches. To connect the sensor and buzzer, I used pin headers and jumper wires for quick and reliable connections. I also used a small prototype board to securely support and mount the display assembly. Now that we have all the components ready, let's begin the assembly process. If you're ready, let's get started. The hardware assembly is finally complete. Now it's time to upload the software. To put the Pico into programming mode, I'm holding down the bootsel button while connecting the USB cable to my computer. Next, I open Thonny IDE and click the install option in the bottom right corner. After selecting the correct settings in the pop-up window, I start the installation process and wait until it reaches 100%. Once the installation is complete, I simply click the close button. Before uploading the code, I make sure that Raspberry Pi Pico 2 is selected as the MicroPython interpreter in the bottom right corner of Thonny. With MicroPython installed and the interpreter configured, it's time to upload the project files. First, I upload main.py, which contains the code that powers the smart desktop station. Right after that, I upload config.py, which stores all the configuration settings required by the project. Once both files are uploaded, the software setup is complete and the device is ready to run. Before uploading the files, you'll need to update a few settings in config.py. Here, you can enter your Wi-Fi name and password, choose your city, add your OpenWeather API key, set the correct time zone, and configure the default alarm time. Once these settings are adjusted to match your needs, you're ready to upload the file to the Pico. If everything was uploaded correctly, let's put the SmartStation Pi to the test and see it in action. Now, let's power up the Pico and see if everything works as expected. As you can see, the device successfully connects to Wi-Fi during startup. Once the connection is established, the DHT11 sensor begins reporting temperature and humidity data, and the SmartStation loads its main interface with real-time information. And that brings us to the end of another video. I hope you enjoyed this SmartStation Pi project and that it has inspired you to create your own version. You can find the project files and the installation guide in the video description. Projects like this require a lot of time, testing, and development. That's why your support means a lot to me. If you would like to see more DIY electronics projects on the channel, don't forget to subscribe, like the video, and share your thoughts in the comments. Thank you for watching, and I'll see you in the next project.